Welcome back to Sri Sampath Vinayaka Learning channel. Now we will discuss the chapter 2 sets. Now we will discuss the definition of a set. Before going to discuss the definition, we have to know who developed or who did most of his contribution to the development of set theory. Okay, that is none other than George Cantor. Okay, now the definition of a set. See, a set is a well-defined collection of objects. Okay, well-defined means what we have to discuss now. We say that a collection of objects is well-defined if there is some reason or rule by which we can say whether the given object of the universe belongs to that collection or not. Okay, that means we have to decide whether the object or thing is going to belong to the required collection or not in that universe. Okay, for example, we will discuss some examples. For example, the best doctors of India, let us suppose. Okay, whether some doctors are comes to that collection or not, we have to check. The best doctors of India is not a well-defined collection because some doctors are best to me, some doctors are best to the some other person. Okay, if I will collect the names of the best doctors, those collections to different people are different. So that is not well defined. If it is well defined means all the persons in the universe or in the world will get the same collection. Then only it is said to be a well defined. For example, Prime Ministers of India. Okay, now whoever is going to list out the names, everyone is going to get the same list of names. So it is a well defined. And we can say that the object is belongs to or the name is belongs to that collection or not. Okay, Nama. For example, the teachers of a specific school, yes, that is well defined. Why? Because in that specific school, whoever is going to list out the names of the teachers, they will get the same collection. Okay, Nama. The chief ministers of, for example, Andhra Pradesh. The chief ministers of Andhra Pradesh means whoever is going to list out the names, they will get the same list. That is why that is a well defined collection. Okay, now next. The best batters in Indian cricket. Okay, is that is a well-defined collection, No, it is not well-defined because the best batters in the sense, to me, some 10 persons are best batters. To some X, those 10 persons are not the best batters. That means the different people are going to list out the different names into the collection. So that's why that's not a well-defined. I hope you understand what is well-defined. Okay, here we will discuss the rules and properties of the sets. As we discussed, we denote the sets with capital letters and the objects which are in the set are known as elements or the members of the set are also known as elements. The sets are represented with this curly bracket or flower brackets. Okay, and each element is separated by using commas. And one more thing here we have to remember, each member of the set, that means element, is represented with a small letter. Okay, that's the rule actually. But in some exceptional cases, the elements are also represented by capital letters. Okay, now what are those exceptional cases means? Sometimes he will give you a word in capital letters. For example, mathematics. Okay, now write the letters of the word mathematics in a set, he will ask us. Okay, then in that case, as the word is in capital letters, while writing the elements into the set, we have to write capitals only. That is the exception. Okay, for example, see the letters of the word mathematics. Okay, as we know that no letter in the set is repeated, we have to write only M, A, T, H, E. Again there is M, but we need not to write that M. Why? Because we already learned that rule that each element is written only once in the set. So the repeated M is not going to be taken. Again there is a. Already we wrote A. So A is also not taken. Next T. T is also written here. So T is also not taken. I, C, S. Okay. Like this we have to list out the elements. Okay. First and foremost thing here we have to remember is no letter in the set is repeated and the members of the set, that means elements, are represented with small letters actually. Okay, now in such exceptional cases we have to write the capital letters. There is no other chance. That is why we have to write the elements are also in capitals, but we have to represent those elements in only small letters. And the set is represented with a capital letter. Let us suppose we don't know the name of this set. Now let us suppose this set has some x, like this. Okay, so set braces, if you don't know how to write, then write s and then 2. On the other side write 2 and then s. If you practice like this, then you will get the set bracket easily. Firstly write s, then 2. First write 2, then s. Okay, now by that you will easily use the flower braces. For example, set of natural numbers. So we know set of natural numbers represented with capital N. 1, 2, 3, 4, so on. Natural numbers means set of whole numbers. W is equal to, from 0 the whole number starts, 0, 1, 2, 3, so on. Integers, we know positive numbers, negative numbers including 0 are integers, so we have to represent like this. Okay, now these are some examples. Now we will discuss a concept called cardinality of a set. Cardinality of a set means the number of elements in that set are known as cardinality of the set. Okay, now for example, let us suppose a set is A, capital A. Okay, the number of elements in that capital A are known as its cardinality. Okay, and it is represented as n of A. For example, see, the number of elements of a set A is called its cardinality and it is represented by n of A. Okay, Nama? So for example, see, the set A is of elements 7, 8, 9, 10. Okay, now how many elements this set A consists? 1, 2, 3, 4. So number of A is equal to 4. Okay, and if any element belongs to that set, then we represent that with the symbol belongs to. For example, see, 7 belongs to the set A. So I will use the symbol belongs to represent the whole sentence. 7 belongs to A is simply represented as 7 belongs to A. For example, see, 5 is not the element of this set. So I will simply write 5 does not belongs to A. Okay, now these are the symbols we have to use to express whether the element belongs to that set or not. Okay, if any element belongs to that set, then we will use the symbol belongs to. If any element does not belongs to that set, means I will write the representation does not belongs to represent it. Okay, 5 does not belongs to A. For example, here see, 13. Is that 13 belongs to A? So no. So 13 does not belongs to A. Like that we will represent the elements. Okay. Now we will discuss how to represent the sets. Actually, sets are represented in 3 different methods. But in many textbooks, they will tell us only 2 methods. Okay, now we will discuss all the 3. Okay, see, my representation of sets. The following methods we will use to represent a set. The first one is skeleton form. A skeleton form is known as a statement form. Simply it is a statement. Okay, the chief ministers of Andhra Pradesh or the prime ministers of India or the presidents of America. All these are the statements which represent a set. That's why this is known as skeleton form or statement form. Okay, this is one method. The other method is roster form. This roster form is also known as listed method. Okay, now why we are going to name that as a listed method means here in this roster form we have to list all the elements of the set A by separating with commas. Okay, for example, see, V is the set of letters in the word apple. So I have to list out all the elements, okay, now into the set V separating with commas. So A, P, L, E. As we know that no element in the set is repeated, only once we have to write the element P. Another example, MB, the set of all the multiples of 5 less than 40. So into that M, I have to write the multiples of 5, okay, as 5, 10, 15, 20, 25, 30, 35. Why? Because less than 40 only we have to write. This is known as roster form. Okay, what we have to do in the roster form? we have to list out all the elements into that set, just separating with commas. Okay. The other method is set builder form. In set builder form, okay, now we represent all the elements with a representative factor. Okay, a set is described by using a representative and stating the property or the properties which the elements of the set satisfy through the representative. Okay, that means we have to represent all the elements of the set with a representative value, that is either x, y, z, any variable, and we have to describe the property or properties followed by the each element of the set. Okay, for example, see, by observing the examples you can understand easily. Let D be the set of all days in a week. Here see, I will represent the set with D. Why? Because he named it. Okay, D is equal to, I will use each element of the set to represent, okay, na, with x. Here this x is said to be the representative. I am representing each element of the set D with x. That means all the elements of the set D are like x, and x is a day in a week. Okay, na? Like that we have to represent in this method. Okay, now the other example, see, let n be the set of all the natural numbers between 5 and 20. Now I have to write all the natural numbers in between 5 and 20. Okay, to represent each element of the set n, okay, now I will consider that representative as x. That means each element of the set n is like x. This is known as such that, this slanting line is known as such that. I may use, instead of this slanting line, semicolon also. Okay, so see, x such that the x is in between 5 and 20, no ma? That's why I have to write 5 is less than, x is less than 20. And I have to describe the property here. Okay, now here this element are the representative belongs to natural numbers. So here the condition we have to write. Okay, na ma? To which number set the element belongs to. If required, we have to write the condition. Else that will become wrong, ma. Why? Because if I does not write x belongs to n means, here I have to write all the numbers in between 5 and 20. That means decimal values also comes under this set. Okay, that is why we have to write the condition first show. Okay, see, that means the natural number set n here in this set, n is equal to x such that, okay, na, that 5 is less than x and is less than 25. Sorry, 20. Now here see, here he gave one set m, 1, 8, 27, 64, 125. Here we have to first identify the property. Here see, all these are the cubes of the numbers. 1 cube, 2 cube, 3 cube, okay, 4 cube, 5 cube. The property here is cube. So I have to represent the set m with the representative y, let us suppose. All the elements of the set m are like y, and y is like something cube, something cube. Here the changing value is 1, 2, 3, 4. The say common value is cube. So in the changing place we have to write k. So k cube. Not only k, you may use any variable. So all the elements of the set m are like y, and y is like something cube. Okay. What about that something k? K is 1, 2, 3, 4, 5. That means k is a natural number. So k belongs to n. And k runs from 1 to 5. So k is less than or equal to 5. Here we have to write all these. Okay, now else that will shows a different set. Okay, see, all the elements of this m are like y, and y is like something cube, and that something k belongs to natural numbers, and k is less than or equal to 5. In this way we have to represent the set builder method. Okay, Nama? I hope you understand.